Hello, and welcome to this week's Ethical Dilemma in Science, where we're going to take a look at revealing hidden figures in an effort to celebrate and support diverse scientists of the past, present, and future. And so this is a topic that I've thought about previously. I've actually used it to introduce some topics within the scientific ethics class that we're taking and I'm teaching. But this is one, again, based on current events that I thought was especially timely. And so I'm expanding it out into one of these full ethical dilemmas in science. You know, we have lots of examples of scientists, women, underrepresented minorities, people from different cultural backgrounds that have done really monumental and important things. But, you know, in many cases, when we go to school, especially in the United States and Europe, we don't necessarily learn about them. We don't learn about their accomplishments. And so is that an area that we need to do better on? And so the kind of kickstart, I'm not sure what happened there. My computer glitched for a second. So the kickstart for this was an article that came out in early July, taking a look at the Jane Goodall Barbie, originally released July 1st, 2022. Into the July now. It's currently sold out. But we're recognizing the very important work that Jane Goodall has done, over, almost 60 years now, I think. And so this Barbie is produced in the cooperation with the Jane Goodall Institute, really emphasizing and recognizing and acknowledging the important work that was done by leaders, female leaders in the conservation and ecology realm. So in this case, you have the opportunity to, kind of celebrate and kind of use Jane Goodall as a model by getting this Barbie with the equipment and the materials needed to go out and do field studies. So she comes with a tent and binoculars and a field notebook. And even over here we've got David Graybeard, the first chimpanzee that Jane Goodall observed and recorded using tools made out of sticks. So really monumental discovery, and so recognizing and celebrating Jane Goodall. Another example of this, again, a woman lost to science that we're just now really recognizing in a way that accomplishes the really significant contributions she made to the field of paleontology. And so Mary Anning was a female working class poor individual, lived along the coast of Great Britain, and she basically was an area that had lots of fossils that are available. And so originally with her father, and then after her father had died, to support her family, she collected fossils to sell to tourists and collectors. And so if we take a look at some of the discoveries that she made, in 1811, at age 12, Mary Anning discovered a 17-foot skeleton of an ichthyosaur, and so basically a swimming dinosaur. A short 12 years later, so in her early 20s, she discovered the first complete skeleton of a plesiosaur, this really bizarre-looking marine reptile that for many years was thought about as being fake, as being kind of a fraud, as being something that was put together and kind of artificial. But it's now recognized as a holotype. It is the specimen that is used to describe the species. She discovered the first known remains of a pterosaur, a flying dinosaur, within the United Kingdom. But as a poor, working-class female individual, she didn't get the recognition of her accomplishments. When they were debating the plesiosaur that she discovered, that bizarre marine reptile, the scientists at the time would debate in the academies as to whether or not this is real or whether it's fraud. And she wasn't allowed in the room. She wasn't allowed into the academy because she was a woman. Now, over the last couple of years, a young woman, a young child, has recognized her and started an effort to collect money and ultimately, over the past year, earlier this year, earlier in 2022, was able to have a statue made of her that is put prominently, displayed prominently in her hometown. And again, so recognizing the contributions that were not necessarily recognized in her time or for many years after that. And then, kind of from the title of this week's Ethical Dilemma in Science, we've got the book Hidden Figures that came out in 2016, followed up really quickly after that by 2017, looking at a few examples, but about 50 college-educated African-American women, female mathematicians, were basically hired as the equivalent of human computers. They would work alongside engineers, white males that had, kind of a better title, but they were there to run tests, produce calculations, and in many ways, because of the environment they were in, they still, they had lunch in segregated cafeterias. They didn't get the kind of recognition at the time for their important accomplishments. They were doing many of the calculations necessary to put a man on the moon. More recently, and hopefully would have come out anyway, but in response to both the book and the movie, the street in front of the NASA headquarters in Washington, D.C. Was named Hidden Figures Way in 2019 in recognition of that. And then members of the Hidden Figures group received congressional gold medals also in 2019. And then finally in 2020, the NASA headquarters in Washington, D.C. Was named after, in this case, Mary W. Jackson, the agency's first African-American female engineer. So somebody that started out as these human computers, continued her training, stayed with NASA, and then ultimately received the title that she was unable to get kind of early on within her career. And then finally, we've looked at other examples of women. We've looked at African Americans in terms of the hidden figures. We look at the fact that there are also different cultural blind spots we may have when we're learning about science within the Western world. And so if we take a look at Islamic mathematicians and astronomers, they were very, very productive between the 8th and 15th century during the height of the Muslim world. And taking a look at the sophisticated work they were doing. They refined the Ptolemaic model of the solar system that was, at that point, the description for how the sun and the earth and the planets kind of interacted. It's since been replaced, but they were able to make some increased measurements, increased sensitivity, more precise measurements, because they developed instruments that allowed them to do that. So they were very good at collecting better measurements and recording these celestial movements and interpreting what was going on and using that information to come up with a better explanation for what was going on in the solar system. And again, something that's not usually covered when we're learning sciences, at least within the United States. And so if we take a look at this, we're in the situation that science, as it's taught in Western classrooms, is taught as this kind of European-American endeavor. A narrative built around the Cold War, coming out of World War II, kind of going into the 50s and 60s, but it's still being held and current in the way that we're approaching the teaching of science now. James Poskett is a historian of science at the University of Warwick in England. Prepared a book, Horizons, A Global History of Science, which basically kind of recognizes and starts to emphasize that, we're losing out. All of us are losing out on the history of science if we don't go back and recognize the important contributions that are made by people that, like the movie, like the book Hidden Figures. They were, kind of looked, they were overlooked in kind of the recording of the history of sciences, at least within the Western classrooms. And so that's a problem. And so if we take a look at this, and again, this is a June 2022 commentary in the science magazine Nature, where they're basically going to be producing a special issue with guest editors exploring the the concept of what would be recognized as systemic racism now in research, research policy, and publishing in science. And they're actually going to have a special issue expected later this year looking at that and trying to get a better understanding for hopefully how we can do a much, much better job of recognizing the past accomplishments and promoting the very diverse views, scientists of diverse perspectives, however you want to think about diversity. We need this diversity of thought coming through. And so, we think about this. We're teaching science in, kind of a Cold War type of way, even though hopefully we are past the Cold War era. But we're in a situation, and I'm thinking about what was originally attributed to Churchill as I start to researching many of these quotes, just because they often have a history that I'm not necessarily familiar with. And sadly, some of the people that these quotes are attributed to have less than ideal backgrounds, and so I've had to replace some of the quotes I've used in the class before. But history is written by the victors, attributed to Winston Churchill. Probably not necessarily Churchill, probably paraphrasing it from somebody else. We've got reports in translations as far back as 1842 in France. The history is right, perhaps, but let us not forget it is written by the victors. It's found in an Italian manuscript in 1852. History of these events was written by the winners. But what I like, because it goes a little bit further, is actually what George Vest said. George Vest was a congressman of the Confederacy, ultimately became a senator, representing his home state of Missouri, but he wrote basically, history is written by the victors and framed, and this is the important part, and framed according to the prejudices and bias existing on their side. And so that's the situation we have with the kind of teaching and learning of science right now, is that we're looking at it from this inherently European American perspective. And because of that, we're missing out on those that were disenfranchised in our culture until relatively recently. And so again, I like quotes. This is a quote by James Baldwin, an American writer and activist in the civil rights movement. Not everything that is faced can be changed, but nothing can be changed until it's faced. And so this is a situation where, perhaps it's time, and perhaps it's well past the time in which we should start thinking about how is it that we can change the way we're doing science? How is it that we can change the way that we are teaching science? And, I would argue that the way we teach science determines who our future scientists are. If we are teaching science in a way and talking about science in a way that excludes certain individuals, they're not going to see the role models that they need to be able to see that as a possible kind of career for them. And because of that, we lose out on their perspectives, and we lose out on potentially their future discoveries and advancements. Now, there are examples throughout history of individuals that are in groups that were disenfranchised and overlooked. A few of them that have been recorded within the history books, but mainly because they went so far beyond expectations that they accomplished really incredible things. Marie Curie, over here on the left-hand portion of the slide, the first woman to be awarded the Nobel Prize. She received it in physics in 1903 with her husband and another individual for their discoveries related to radioactivity and radioactive chemicals. She went on a few years later in 1911 to become the first person out of four now. So the only woman and the first of four people to have received multiple Nobel Prizes. She received the Nobel Prize in physics in 1903, the Nobel Prize in chemistry in 1911. And so because of that, it's kind of hard to overlook her if she's being recognized for these, kind of height of career type awards like the Nobel Prize. On the other part of the slide, on the right-hand portion of the slide, we got a picture of George Washington Carver. This was an individual that was born into slavery. He was born, I think it was 1864, so about a year before the Emancipation Proclamation ending slavery. And so he was the first person, first African-American person to earn a Bachelor of Science degree within the United States. He went on to become a faculty member at what would now become Tuskegee University. And he spent many, many years researching kind of agriculture focused on improving conditions for poor Southern farmers. And so he started out with, kind of enriching croplands with swamp muck, the kind of mucky mud stuff that kind of ends up in the floods with, a lot of decaying plant matter, but it's got a lot of rich nutrients. But it's a lot easier and a lot cheaper to use swamp muck as opposed to the cost of purchasing fertilizer. A big proponent of crop rotation, and so kind of growing things, crops for sale, but then on an off season, doing a crop rotation, putting in some type of nitrogen fixing plant, like peanuts or soybeans, that would enrich the soil so that you could put your main cash crop in again. But basically, the peanuts, growing these nitrogen fixing plants, made the soil much better for the cash crops they had, but generated lots of peanuts. And so he's very, very famous because he developed over 300 uses for these surplus peanuts that were produced by this crop rotation kind of scheme to enrich the soil and reduce the need for putting, kind of artificial, kind of man-made chemicals or materials that are necessarily, kind of not the ideal for, kind of the equivalent of organic farming if we were thinking about now. But these people, Marie Curie, George Washington Carver, other examples of it are few and far between when we take a look at that, when we talk about the history of science. Now, this is an article that came out of perspective within the Proceedings of the National Academy of Science, really emphasizing the fact that we've got a problem in science today. We've got this kind of problem with representation. We've got this problem with diversity, and we need to improve diversity of experience, diversity of thought, in order to be able to come up with better approaches at science, improved understanding of these concepts. Because if you do the same thing in the same old way, you're going to get the same result. We're advancing science. We're learning through science. But it's important that we have diverse perspectives because we need those perspectives to be able to advance science much faster and more completely and more robustly than what we've done in the past. So just a couple articles, and I'll link these down below within the notes, looking at different programs for promoting diversity within the scientists. So the first one is taking a look at mentoring of female health academics. The second one is looking at programs that, again, are focused on mentoring and supporting underrepresented minority faculty in health-related research fields. And again, I'm a biologist, so I kind of navigate towards these a little bit more, but hopefully other examples in other science fields as well, to go through and develop specific programs to promote diversity in the science, to promote opportunities for individuals that may not necessarily see themselves as scientists to pursue that as a field, again, assuming that this is something that they're interested in, to go well beyond that concept that, well, and I'm a father of daughters, so, you see, women shouldn't be doing math because women aren't good at math. No, that's not the case. Women are very good at math, but women are discouraged when they're in our education setting that, they should be looking at other things. Now, hopefully this is getting better, but, maybe this is something we need to, intentionally do. Like the quote we had earlier, in order to make change, we need to be able to face the issues and identify what the problem is so that we can address it. And that gives rise to the ethical dilemma in science. I'm actually looking at this from three different perspectives: the past, the present, and the future. And so, taking a look at this from the past, how do we recognize and celebrate the important scientific accomplishments of individuals that have been overlooked in the current teaching and understanding of the history of science? We're looking at women and minority groups and individuals with different cultural backgrounds and the incredible achievements that they've done that in many cases were overlooked, or in some cases attributed to others, in many cases attributed to, sadly, the male kind of head of the lab or whoever it was that was doing it, just because science was looked at as a patriarchal endeavor. It was done by men because there weren't opportunities for women, minorities to be doing that. So how do we recognize that? Do we change the way that we're teaching science? Do we intentionally kind of learn and include examples of past scientists that have done important things that we don't always talk about as examples of role models? So that's the past. Moving into the present. How do we support scientists with diverse perspectives and backgrounds in school so that they're not discouraged and drop out of this kind of career path? How do we support them in the workplace? Sadly, we still find instances of racism and sexism and all kinds of other kind of hostile work environments. In many cases, kind of attempting to exclude, people that don't necessarily look like everybody else within the room. And so how do we promote that so that they have a safe and supportive environment for which to work and flourish and hopefully serve as role models for that next generation of scientists? How do we promote and support these scientists in society? So that we get a more complete view about what it is that a scientist. A science doesn't necessarily look like an old white guy in a lab coat. That we can have very, very diverse perspectives and include that in our understanding and in our discussions of what science and scientists are. And then finally, the ethical dilemma: how do we support this in the future? How do we encourage and develop future scientists from diverse backgrounds and diverse perspectives? How do we make sure that they're not lost in the K-12 education by being discouraged because, maybe you don't want to do that. Maybe you want to go and do something else, and being discouraged by people that have their mindset about what a scientist or what a mathematician or what a doctor should look like. How do we promote that so that people aren't discouraged, that they have the opportunity to pursue careers that they're interested in? Hopefully get them into college and be able to better support them so that they get the opportunities. They get research opportunities, they get internships, they get the networking opportunities to be able to get into a wonderful graduate program and move forward on their career path. And then finally, how do we make sure that once they get into their professional careers, they're supported and not discouraged, not driven out of it by a hostile workplace. And so how is it that we can do science better to bring more people into the conversation, more people with more diverse perspectives? And so again, not quite sure what any of the answers are, but I'm sure that we're not going to come up with the answers if we don't think about it and attempt to come up with a better solution going forward. So that's it for this week's Ethical Dilemma in Science. Thank you for listening. As always, I'm going to provide additional information as well as the references, at least the key references that I think are important in the comments down below. So if you want more information, you can find it there. So thank you. Have a great week, and we'll have another Ethical Dilemma in Science for you next week.